The communication is expensive, so trained astronauts, they will not want to overuse communication with MCC. Second thing, even if they disagree with some new problems emerging during their trip, they will not want to disagree because this will break the harmony in isolated, confined team. So they will not want to speak honestly. They will try to keep balance, keep going, follow procedures, operations, and the cognitive state of the crew will not be easily visible because they will try to hide all stuff like this. Imagine unplanned emergency that we never imagined. In deep space, something completely new can happen. And with this thing, imagine that engineer will start to do engineering, to solve engineering problems. Biologists will start solving biological problems. They will not work together. And this means that the cognitive performance of the crew may be disturbed. Longer trip, more problems with cognitive performance. So I believe that the blind spot is to treat the mental health, the cognitive state of the crew as the life support system. And we need to do a lot of study on that, how to prevent all problems with the cognitive performance of the crew during deep space missions. Thank you.
Thank you, Agatha. Now coming to Matt.
Good evening, everyone. This is an honor to be with this distinguished guest here in the panel. I would like to elaborate on what Agatha said. Currently, there's a field which is called analog astronautics, and the problem with this field is that many people believe that going out on a desert, putting motorcycle helmet will make them astronauts, and this is something that we would like to change. Publishable, verifiable, peer-reviewed science. This is the most important. Because what Agatha said is very important, so tackling those problems. Yesterday I checked the stats and there was 635 people who flown to space. This is not very strong statistical group. And the biggest problem of that is that all of those people are pre-selected, they are very healthy individuals, top-notch, they are absolutely the best of what humanity can serve. But right now we are on the edge of opening for the commercial human spaceflight. There will be more and more jobs available for normal people to be on orbit. There's 9 commercial space stations which is currently being built, and we need people to maintain those space stations. We need people who will take care about HVAC, who will take care about well-being of personnel. We need medical personnel. We need also people who will take care and maintain the equipment. So there is a new generation of people who is going to be working in space. Not necessarily astronaut as a scientist, highly trained, skilled personnel like we have here, but also people who will just serve, just work there in space. And this is what we want to do. So 2 things. Publishable, verifiable, peer-reviewed science, and open to commercial human spaceflight, which will be more generally available.
Thank you, Matt. Now coming to Mohan.
Hello. Good evening, everyone. I think for me, from my experiences, especially through analog missions, I always believe start with understanding survivability. How do you want to survive? Or how do you want to sustain of your own self within these expeditions and missions, and then start thinking about the science. So survivability and science is something I always try to balance and prioritize, and that's what exactly these analogs does through putting us into isolation and confinement. So isolation and confinement is something definitely help us whether to make or break in the missions, which make me to add what Angad sir also mentioned about the high fidelity aspect. So when we have high fidelity missions or high fidelity simulations, it actually helps us to understand each subsystem. You can score a mission based on fidelity, how accurate the mission is, but when we try to understand within that fidelity also, when you try to see subscales, sub-components of each and every aspect of the fidelity, then we could, when it is cumulatively adding to the score of how maximum it can reproduce or replicate, that's when it can be helpful. The other thing I want to add to Dr. Agatha is, especially for deep space missions, the interpersonal dynamics is something very much prioritized. Now there is this statement that says the most fragile element of the human spaceflight mission is the human itself. So for that, crew resilience and interpersonal dynamics, especially in the context of long-term space missions, is at most important. So thank you. Sir.
Thank you, Mohan, for bringing very important aspect. The most fragile element is the human itself who is going to be in space. So that is yes, I think, which tells that yes, we have to first train the human itself who is able to take the psychological changes which is going to happen in space. And I think we have got a very, very strong experience. Gaganyatri designate with us, Angad, who has gone all sort of training which is required to be an astronaut, and he is one of the 4 Indian Gaganyatri designates who are supposed to flow for Axiom 4, and out of these 4, 2 have gone to US for the final training, and then Subhanshu Shukla was there for that historical mission. So Angad, coming to you again, I would like to know what is the most important safeguard we need to build into life support displays to reduce the crew cognitive overload?
Okay. When it comes to the displays part, you are talking specifically about the life support functionalities. So we always have to remember that, for example, I'm myself responsible for designing the cockpit of the Gaganyaan. And in that, when I'm thinking about medical pages where the crew biometric data is being fed in, the worst case scenario is the worst thing that is the worst time when the particular HMI should be able to support me. In that, when we are not in touch with the Mission Control Center, in which the relevant flight surgeons will be available, who will be able to process large amount of biometric data or the physiological data, when that contact is not available, the same information which is being dumped on the human-machine interface. So suppose, let's say, you and me are flying to space and something was going to go wrong to you. The most difficult thing, whether it is a piece of hardware inside an aircraft or a spacecraft or a human being, if I can consider him as a subsystem, is to understand what has gone wrong. That is the first step that you need assistance in, because as much as late you realize what has gone wrong and you start taking actions, you are feeding in problems. So that is one key area, that the interface should be able to assist me in diagnosing the condition, utilizing some sort of, let's say, AI, and also tell me what are the immediate actions to be taken akin to that of a doctor, to a varied level of accuracy, good level of accuracy. Yeah.
So I think he has brought very important thing, that how AI can help in this particular field in assisting the astronauts who are there either in the International Space Station or in deep space, that how they can survive and how they can circumvent the problems what they are facing. Now coming to again to you, because we have heard Angad, who has already gone that all sort of training. Now the trainer himself is available with us, so I would like to know your development of Habitat OS tackles the digital nervous system of an isolated base. To the corporate leaders and space tech startups here, you have seen that they are available here. How do we establish global software and engineering benchmark so that the decentralized life support system remain fail-safe without real-time support from Earth. Because when we are talking about deep space, Agatha has already told that communication is the real problem. So, what is your take on this?
When I was working as an engineer at European Space Agency, I learned that resiliency is more important than designing for the proof software. So basically what this means is that imagine that you have a car, and it's very hard to create a car which wouldn't be able for a car accident. But you can design the systems which will save and prevent loss of life or injuries. We have seatbelts, we have airbags. And this is exactly the same. With the software, we can design software the way which is fail-safe. So, and automatically recover from the failures. And the same with the life support systems that given the interfaces to different modules of the life support system, the air conditioning, the air quality management, the water recycling system, and CO2 scrubbing, we can design all of those systems to have common interfaces and communicate on a system bus, and then with those information we can put them in one centralized piece of equipment which can enable the crew to understand what our distinguished guest here said, that we can inform crew about the most critical parts. For last 7 years I was trying to understand the problems which can arise in the habitats, in the spacecrafts, and put that knowledge into the context to create operating system which can fail safe, recover from those failures, and provide information to the crew. So one learning that I have with the AI, it's great support, but cannot make the decisions. And currently, when there was Artemis 2 mission around the moon, there was no AI in the spacecraft. In the age where the AI is omnipresent, we all have mobile phones, and on our mobile phones we have all apps which are AI enabled or something like that. In mission critical software, AI could be a support, but the final decision should be to the highly skilled personnel, astronauts, who are trained how to operate this. So AI could be a very good support, but the final decision should be up to the astronauts.
That's a very good point, that AI can be a support rather than the decision maker itself, and it is ultimately the astronaut who is there who has to take the decision for his or her survivability. Now coming to again, Agatha, to you. Your active biosignal time experiment inside the 100 days Solace 100 mission tracks critical time distortions in isolation. From an academic standpoint of view, how can global universities seamlessly transfer this kind of psychological and behavioral data into active R&D pipelines of their own national space program? And I just know you have just told that only 365 such data sets are available. And when we are talking about deep space exploration, which has a lot of uncertainties, much more than the LEO where our ISS is there, then what kind of additional testing and other things can be brought in which gives us a fair amount of information that yes, this is going to happen and this is the thing you should be doing?
Thank you for this question. Indeed, the German Space Agency announced call for researchers to participate in 100-day isolation mission. They collected and selected 6 participants, and even now they are performing this analog mission in German Space Agency. My project was selected and I'm principal investigator of research that is testing subjective time perception in full isolation from sunlight during 100 days. So the crew cannot see the sun, the crew is only going in active phase and sleep phase using artificial light, and we are measuring several physiological parameters which will tell us how circadian clock works in such an environment and how cognitive performance, so subjective time perception, is changing during this long-term analog mission. And what I learned as a researcher, academic person, is that space agency asked me to standardize my data. So to standardize all methodology that I want to perform in this analog mission. I had to fill in several documents, operational documents, so I learned how to, write very carefully, step by step, the checklist, what analog astronauts needs to do. And this is learning us, academic researchers, how to collaborate with space agency. Space agency needs to have a very well documented procedures, operational procedures such as standard operation procedures, SOPs. And this is very important because we can standardize research all around the world, globally. This same standardized methodology can be applied. And again, the space agency is learning us how to share data, how to protect personal data. This all we learn from space agency. What we researchers can give to space agencies is our fundamental research. We can, propose the way how to solve some problems that can happen in deep space with astronauts or with other life support systems. We are testing them with space agencies because they can give us opportunities. Like this, Solis 100, this biosite time experiment, is the example how space agency can invite researchers to collaborate. And we are having opportunity as researchers to work with space agency. Space agency can use this research to prepare future spaceflight operations. So this is a very interesting collaboration. Also, space agency can show us researchers what are problems, what are requirements, and several universities can answer to these requirements. We have this research. Are you interested in testing this research? So, times are changing. We never had this kind of opportunity that space agencies are starting inviting researchers, collaborating with them. But also universities need to be prepared with this. So already we should develop. Even space agencies are not yet asking, calling us researchers, come and solve this problem. We should already start in our universities to do it, and then when space agency is prepared, then to collaborate.
Thank you, Agatha. I think you have brought a very important aspect of standardization of the entire activity. I think there IEEE can play a very, very important role in standardizing the overall process of research itself toward the human space exploration. Thank you, Agatha. Now coming to Janvi. Janvi, you have been part of several analog space missions as well as trainings. In fact, you have gone to AATC Poland as well and in Russia as well. So from your point of view, what is the single most important thing which best prepares future astronauts for the realities of human space flight and deep space exploration?
Okay, this might be a very normal statement, but the ability to work in the team plays a vital role because space exploration, whenever I think about a mission, the human space flight, I feel the fundamental is team endeavor. While technical expertise is essential, what what consistency determines is how well the crew is communicating, performing, and able to coordinate with each other when there is an uncertainty among the team. And from the trainings or the simulated missions so far I've did, what they've taught me, like it gave different experiences, gave me different lessons, whether it can be working in extreme environmental conditions or collaborating and working with international teams or managing very limited resources or conducting scientific experiments. But those have reinforced that astronauts are trained not just to perform procedures but to remain calm and support each other when there is a sudden change in plans or something that goes wrong. And to me, these simulated missions are like the greatest platforms because they're not just testing the technologies, they're not just acting as a test beds for technologies, but they're testing humans. And they help us understand how humans live, work, and adapt to those extreme environments which demands extreme discipline and resilience, and these lessons are very essential for longer duration space missions to the moon or Mars, which are actually currently using for human space flight.
Thank you, Janvi. Thank you very much for bringing very, very important aspect and telling that for deep space explorations where larger isolation time is required. So these are the things you have to have it. Now coming back to again Mohan. Mohan, you know, yesterday I was having some very short duration attendance in presentation of Matt. He told that when you are at International Space Station, especially for the maintenance work when you are going outside, because of the sheer velocity of the International Space Station and the drag which is available there, it is very tough to do any maintenance activity. But you have to do it, because without that you cannot survive there. So towards this, what is your point of view, how automotive sector can help space agencies or astronauts in finding out some mechanism for automating this entire work, which is with respect to the robotic arms as well as the vehicles or rovers which are there in the interplanetary missions. So how we can take the expertise available in the automotive sector in this particular field?
Thank you, sir. Two things, operational workload and robotics under the umbrella of, let's say, EVA, if I can sum it up as EVA. So these two things I'll quickly answer. In one of my analog mission in Poland, I got exposed to understand what it means to be performing EVA. Right from the beginning of reading the protocols, understanding the manuals, and also understanding your co-crew members' role in EVA. Because technically once you're out of the ISS or on a terrestrial EVA, you are by yourself. So in that context, lot of robotics and lot of machines are going to aid you to bring you back safely. So in that context, we were trying to understand how rover operates before taking it to the field. We were just trying to understand how battery can endure, how many times. Is it going to be same if the terrain is flat, or is it going to be different if the terrain is harsh? So we were just trying to understand running the rover and understanding the battery endurance, so that, because technically even when we go into EVA, we are also on time, the oxygen capacity or everything. So you have to aid multiple aspects. At the end of the day, whether it's rovers, or we also had a device called LEMS on our wrist. life engineering management system. You know, it gives complete and on-time, real-time information that talks about astronaut parameters, body parameters, and also suit parameters, your EVA suit parameters. Now, in the case of communication loss or any kind of loss with the habitat support, the immediate aid you get from is your LEMS device, so that you don't get into panic and you get failed in achieving the objective. So devices like these or technology like rovers, when we have, especially in the context of decreasing the workload for astronauts and helping them in completing the mission objectives, especially on EVAs, is a great help. And we no more see as external machines, but we see them as an additional crew member, and that's what really makes us feel good about risking things. So for the corporate automation sector, just concentrating on interfaces and automation, especially keeping the center point as how can you decrease operational workload for astronauts in the context of robotics and EVA is something much more important. Thank you.
I think you have really brought a very important point, how they can reduce the total or overall operational load on astronauts so that they can utilize that time in doing science experiment and other things. What I understand, the most of the time on ISS goes in maintenance of the ISS rather than doing the real science experiments.
Yes, sir. Yeah, that's an important thing. Astronaut can concentrate on scientific experiment than troubleshooting the equipment a lot. So, yeah, that's it.
Thank you very much. Now again, I started my discussion with Angad, and I would like to end this session before opening the floor for the audience. So Angad, you are involved in, from beginning, all the design activities of the Indian human space flight mission. And now, while we are preparing for the human space in the LEO orbit, we are also talking towards that by 2047, Indian is going to be there on moon itself. It means we are talking towards deep space exploration. So I would like to know very basic question as an ordinary man. How different is going to be the selection process when I am going for a LEO vis-a-vis when I am going for a deep space exploration?
Okay, sir. Thank you for asking this question. And of course, most of the questions to all the participants are towards deep space. Yeah, and I can get that drift. Before answering this question, I would like to first of all thank Matt and Agatha because they've shared some really good perspectives that I wasn't aware of. And we need to understand that there is a lot of gold standard level kind of research which happens in all the analogs that are conducted across the world. Most of them for human space flight, they are in the domain of deep space flight and not as much as the low Earth orbit operations, which is probably the first thing that we must be doing. But since we are already ahead, so all that is going on. We need to understand one thing, that as a species today, we human beings are not able to send a lot of people to space. That is one reason why we have such restrictions. I am an overtrained person, and so is the case with most of the astronauts. We are overtrained for the task that we are expected to perform. But humanity can send, or has been able to send, only 653, you said? Okay. That many people only. There are two reasons to it. One, that we could send only these many, so instead of a selection criteria, we have a sort of a hyper-rejection criteria, in which we can find reasons to tell, okay, you are also not there, right? This, I'm talking primarily for the government missions and the regular classical astronaut that we talk about, not the commercial ones. And the second thing is that when you go to an extreme environment like space, forget about space. It's a different kind of an extreme environment. There are enough number of extreme environments here on planet Earth. be it the mountains, be it the subsurface ocean, when you do scuba diving at crazy depths of 100 meters, 150 meters, 200 meters, and polar regions, polar expeditions, multiple extreme environments exist here on planet Earth to go and check yourself out. You need to understand one thing, that at the end, we humans, we need to get comfortable with the environment is all that it's required. All these things are very much trainable if you've done a basic screening at the time of selection. There is every time that, oh, I'm sending somebody to lunar, so he needs a separate set of instructions or capabilities at the point of selection. And for Mars, they'll be different. And let's say, hypothetically, Jupiter was a surface planet and not a gaseous one. So no, but Jupiter is further away, so I'll have even greater. There is no end to this. What we need to do is integrate the gold standard research that these people do by putting in so much of effort, putting people inside, 100 days of isolation. It's all about exposure. It's all about expected human behavior. You are expecting the human to behave in a particular way in an extreme environment which is not as comfortable as planet Earth. It's just an expected way of performance. That person has to come back finally to Earth and behave the normal way, right? So rather than saying that I'll do it as a selection criteria, I'd rather train the already trained people along those lines. And these people that we are talking about are highly trainable people, highly efficient people. But yes, we need to integrate that data and not maybe, talk about 25 years from now when we are an interplanetary species and everyone can go. Would you do that? You know, I'll put you through those extra set of psychological evaluations and I'll put you into isolation. A basic human being is very much capable of being trained to go and survive in such extreme environments. Is all I would say. Yeah. Thank you.
Thank you, Angad. Thank you very much. Again, bringing the very important aspect of 100 days of isolation. In fact, none of us can survive with 100 minutes of without mobile. So 100 days of isolation, what will be the rigor one has to have and psychological courage one should have. So I really appreciate all of you for going through that rigorous training and successfully completing that. That is more important. And yes, I fully agree, Angad, with you that there is no need of having for any specific data sets or training for going to deep space exploration. And if you will start doing that for every mission, there is going to be again a selection process. But yes, we should have trained astronauts, and then we can build over and above that what additional requirements, if any, are there to be there. So guys, now we are going to make the floor open. So I hope you are ready with your questions. So first question, yes, please go ahead. Can we pass the mic? Otherwise I will not be able to talk. Yes.
So, I'm Dhruv. My question is addressed to the group captain Amita. So, sir, basically you are a fighter pilot. So, did your fighter pilot experience really help in while you were training for the astronaut? And what do you think, like, when we are training for the future, when we are training the future Gaganyatris, like, do the training pilot experience will help, and should we take the IAF SOPs for training the future Gaganyatris? And in regards to the selection process which you told earlier for the astronauts, do you think the SSB process which we have in the Indian Army?
I think we got your point. So you want to know whether only Air Force pilots are to be trained for astronauts. Thank you very much.
Okay. The question that you ask is that how much that training helps. So you have to understand that in order to become an astronaut, two fields of training are extremely important. The first one is aviation, and the second one is a very good level of grasp on engineering. Because these two core sets are absolutely essential. So if you're an engineer, you'll have to learn a little bit of aviation if you're a core aviator, you'll have to learn a lot of engineering as well. So I won't say little bit of aviation, a lot of aviation. So that ways I had that advantage. Being a fighter aviator, it gives you a good level of confidence because a fighter aircraft cockpit is something which is a realistic simulator for a human spacecraft. Okay, but having said that, because I am from the Air Force, every astronaut need not be. Okay, it is a function of how matured your space program has reached. I and the 3 others, we are here because of our test pilot status. We are trained to be a part of prototype development phase of any fast-moving vehicle, whether in the atmosphere or space, and that's the only reason why we are here. Once the prototype stage is over, the phase stabilizes. I don't think it would be mandatory, but yes, as a matter of safety, 1 or 2 crew members amongst many, if they are from this background, it will add value in the domain of safety. Yeah.
Thank you. So I would request each one of you to be very crisp so that we can have more and more questions. If you give larger background, we will have very less questions. Yeah. So over to you. Yeah.
So myself, Charan Raj. So nowadays we see privatization of space rising. That will increase missions which are focused on ROI. So what is your opinion on it affecting the missions which focus on curiosity and exploration?
Matt, would you like to answer this?
I believe that exploration missions are really important. This is what defines humanity, to push forward. And currently the state of the... So I really like the answer of Anga. So basically he said that we focus heavily on deep space exploration, but a little bit of missing is for the low Earth orbit exploration. So I think the commercial ventures, the commercial human spaceflight, will be focusing right now on low Earth orbit, and this is where those companies, those space stations I mentioned before, this is where we will be heading. But government agencies and astronauts selected during the selection process will be pushing forward to explore. And we already seen this trend. That was exactly the same with the aviation. The first start of the aviation was by governmentally sponsored. The first flight was from the military background, from the background sponsored by the government agencies. But right now, only selected few is flying fighter jets, high-performance jets. But I came here by the plane, okay? And I'm not a fighter pilot. I graduated from the Air Force Academy, by the way, but I'm not a fighter pilot. But this is for everyone. And I believe that this is exactly what will happen with the space. With more access, we will leave exploration, deep space exploration for governments because they require higher budgets, they are more risky operations, and this is the only thing which can government do. And low Earth orbit, and hopefully in years to follow, also the lunar orbit and maybe lunar surface will be somehow commercialized and available to all of us.
Yeah. So I think what Matt has told is very right, that the deep is exploration because of the sheer cost. They are going to be there, I think, next at least 1 to 2 decades in the ownership of only government. Whereas when we talk about the space tourism, definitely that is going to happen with the private entities because they will see a lot of value towards that, and with easier access and several launch vehicles coming from different companies as well as different nations, we are going to have a much lesser cost access to the space. Yeah, now next question to you. Yeah, please go ahead. Last one. No. So I think this side is more active than this side. I'm not getting any questions from this side. So anybody, especially students, be ready. Yeah. Let us see which side audience are more active and more dynamic and participating.
Hello, sir and ma'am. I'm Samyadeep. My question is, you frequently mentioned that 100 days isolation simulation. You guys obviously did a psychological profiling on everyone. So how did it change from the 0th day to 100th day? And how did the critical decision making process change overall? Like, did it affect their decision making on critical things? Like, did they start thinking all the consequences?
We got your point. So I think Agatha, you should be the best person to answer this because you have done this session. Yeah, please.
I don't know if I heard correctly because there is a huge echo and I couldn't really understand what you were saying.
No, he wants to know we are telling about 100 days of isolation. When anybody goes for this isolation, what are the changes from the 0th day, in the first day, and when he is coming out of that isolation on the 100th day, what kind of changes are there? Hope I am correct? And in the critical decision making, how it is going to affect that isolation.
So I'm not running 100-day isolated missions, but I can say that already after a week, 7-day isolated mission, the cognitive performance is changing in the crew. Why it is changing? Because there is a huge workload. There are many tasks, operational tasks during the mission. The crew is very busy and there are many constraints. High psychological stress because we need to follow the rules, procedures. All tasks must be done with a specific level of quality. And I understand that for longer periods, this stress is sustaining and it is causing more and more deeper problems inside. Psychologically, it doesn't look, outside you still see the same person, but inside the person can lose motivation, can get into somehow routine mode to survive, and of course everything is changing. We are observing huge changes in psychological appearance and performance, mostly communication. Again, I will be back with communication. Even after 7 days of isolation, people decrease to communicate because they think that they know what they should do and they have no need to communicate. It is not good. They should communicate, they should still continue exchange of communication with crewmates, but they are not doing this. They are very focused on their tasks. So in the long-term period, for long-term missions, it may happen that some people will work in one shift, others in another shift, and this was for Mars 500. During 500 isolation mission, there was a huge conflict within the crew. The crew couldn't sustain each other, so they were switching when they wanted to work, not to see each other. Can you imagine this situation?
The rigorous psychological selection is something, and this is very highly rejective process, okay? So there is many applicants, but we reject most of them and we leave with 4 best ones. And this is one of the experiments that we are running in our simulations, and we already put through 610 people through this experiment. So we are collecting psychological data on them, like a very detailed psychological process. And we know their behavior during the mission. And after the mission, we know who is good, what kind of traits they had, and who performed well in the isolation. So what we are running right now is we want to put machine learning to discover the trends. So we know that person X performed very well during the mission. So what was traits in his psychological survey that predisposed him to be good person as a teammate? This is exactly the same problem what they have in the polar stations for winter over. This is where it's very hard to opt in person to say, oh, this person has exactly the traits we need. It's very easy to opt out. We don't like this person because of X, Y, Z. So what we are doing here is to reverse the process. We look at the performance during the mission, we analyze that, we do the correlation analysis with the psychological profile, and we are looking at, for example, people who are very good in the mission, they scored like 80% or more. In the question number 17, they prefer answer D. We don't know what's the question. This is for psychologists to analyze how this refer. But the computer, the algorithm can pinpoint, can locate those traits which predisposes personnel. And putting more and more people through the process will give us statistical power to answer that questions and follow up with the research.
Thank you, Matt and Nagata. So follow-up questions we will take. Just 1 second, we will go. One question from this idea, please.
Hi. As space systems go higher and higher up in the level of autonomy,
Like this, you take and then speak. Yeah.
as space systems go higher and higher in terms of level of autonomy, 20 years later, maybe 30 years later, there will be nothing for the astronaut to do anything in the space, I believe. So in that scenario, how will you convince a person to go to deep space alone in isolation and doing nothing while at it?
So who would like to answer? I think there is a lot of echo, so we could not hear properly. Can you repeat?
No, I could understand, so I'll answer. So that's a question that you're asking, like human versus machine kind of a question, right? Right? Greater and greater autonomy. Please understand that the greater and greater level of autonomy that is being built continuously is always to ensure that the human on board continues to have greater and greater level of spare mental capacity and workload for other tasks. It is not with an aim to ensure that one day the human is out. Please understand one thing, that when it comes to the sheer potential of a human being, there are a lot of scientists here. If I can take one very capable senior scientist all the way to Mars, make him land on that surface, the way he will see the entire thing and the kind of appreciation he will come back and tell us, equivalent AI will probably, you'll have to become God to be able to defeat a human, right? Because you'll have to create a human being. And always remember one thing, there's a rule. I'm a flying instructor. There's a rule we say that if I'm a flying instructor, I cannot teach another pilot skills that I don't have. Right? So it's impossible for us to create something more superior than us because we don't know what it is. Right? Notwithstanding, please understand the potential of a human being, whether he is in the role of a doctor or an engineer, in the role of a scientist or an aviator or an amalgamation of all three as an astronaut. You can always say that, oh, in this particular field, this particular piece of hardware will be able to perform better than you in terms of temporal demands, in terms of a lot of other logical reasoning and everything. But the sum potential can never be better than the judgment and real-time decision making of a real human being.
Thank you. Yeah.
I'm here, sir. Thanks for that great answer, sir. So, I just understanding that this rigorous training of keeping people in isolation and their experience.
You know, for a very funny point, I asked ChatGPT, putting this poster, what do you think about this? It told me, like, this is what I'm feeling, Subbu. For centuries, that question led us across oceans, over mountains, into the skies, and today it leads us beyond our planet. And you are going to see those people who really achieved it and who are going to make it. So we have Punit Mishra sir as a moderator, as I again said, who is architect of designing most creative conferences in India, and who is also general chair of Space 2026, distinguished scientist, and also distinguished lecturer in EASS community, and DOJ member of EASS. So with that, sir, over to you.
Thank you, Subrahmanya. So, a very good evening to all of you. I know our panel sits between you and the dinner. That's why we have started the starters for you so that you can sit and then we can have a meaningful discussion here. So this important panel, what we wanted to have bridging simulations and Earth orbit missions, engineering the future of deep space exploration, is meant to be the panel where we are going to discuss the technologies which are essential, and towards that, what kind of simulations we can do on ground so that when we are really going to the deep space, we are not missing anything. Because in space, we call it a zero defect. Our quality policy is zero defect. We cannot afford any error in any of these space missions because they are catastrophic. And if we do that, there is no coming back. And when it deals with the human life, you can think of how important it is that we should not be doing any kind of mistakes. Towards that, we should not leave any stone unturned, which is required to simulate all those options, all those conditions which may or may not happen in the space. We are very honored to have our very, very distinguished panelist, Group Captain Angad Pratap. I think he is coming for the second time to IEEE space. Last time he came, and along with that, Gio and others there. But this time we are having a very, very expanded panel. Air Comrade Prashant B. Nair could not join us because of his personal emergency. His daughter needed his immediate attention, so that's why he could not come. He just immediately has sent me a message that he is not able to come. But we are having another Gaganyatri designate, Angad Pratap. So welcome Angad for joining us. And last year when we did the panel discussion, we found that there is a lot of interest among participants to become an astronaut. And to become an astronaut, analog astronaut is the first step. I would like to say that. And to have that, you should go the way we go to our nursery or primary, first, second, third, same way you have to go to an analog astronaut training center. And we are having two very, very eminent pioneers in that particular field. Mr. Matt, who is the director of Analog Astronaut Training Center, Poland. He is with us. So welcome Matt for joining us. Another important aspect is astrobiology. We are having a very distinguished professor in that field, Agatha, who is joining us from Krakow again. Welcome Agatha. So they will be bringing the perspective of Analog Astronaut Training Center and then the real analog astronauts who have been there, who have gone through all this training. We are having Janvi. Welcome Janvi. And we are having Mohan Sayakula as well. Both of them have gone multiple trainings as an analog astronaut, and they have also been working together with Agatha and Matt. And they were they have given very strong recommendation towards them. So that's why we have invited them. And yesterday we were having a workshop on space medicine and biology. I was surprised to see the enthusiasm among the participants, and the workshop was full. And as promised by Matt, despite several challenges, we could get a space suit which he wore and showed the participant that how a space suit looks like and how important it is there to be surviving in space. So with this very, very brief context setting, now we are going to have this panel, and this is going to be a round robin league. We will be going first questions and then we will okay. So, but I will start from Angad. the opening round, which is a 1 minute round where all of you have to speak. What is the single biggest operational blind spot, in your opinion, we risk overlooking as we transition from LEO to deep space?
Okay, when we transition from LEO to deep space, and I will always talk in context of the human space flight missions.
Yes.
One of the things which we always end up overlooking, and I'm not speaking only from a perspective of a pilot, maybe a person who's sitting in the mission control center down below, is the way the things will play out inside the spacecraft in terms of the entire mission flow. And it's that it is extremely important, something which is very much there in the aviation world, is to build as much as a high fidelity simulator. And if you have a high fidelity simulator which is able to replicate the entire exact, or replicate the exact conditions that you're going to see, while factoring in everything with a great degree of high fidelity, I think from a point of safety, you have addressed most of the things.
So, Janvi, I would like to hear from you.
Okay. The blind spot would be treating deep space exploration is purely a technology problem. Beyond low Earth orbit, crew autonomy, communication delays, and also limited resource can redefine the technical operations or the mission operations. From my experiences through the simulated missions, I have learned that critical challenge is human system integration. Ensuring crew can make them take effective and safe decisions when there is no support from Earth, no immediate support from Earth, and that's what I feel it's important. And one more thing I want to add is, if we don't develop the technology with operational resilience, then even the top advanced technology can never guarantee us with 100% operational mission success.
Thank you, Janvi. So guys, I am going to open this floor for 20 minutes to each one of you. So be prepared with your questions. So please hear what they are saying. So this panel is going to be having a 20 minutes of Q&A session. So be attentive, and if you are having questions, please write down and be ready. Now here, when I am going towards my right, ladies first. So Agatha, I would like to hear from you.
Okay, good evening everyone. It's my